This is problem number 18 from the August 2017 Algebra Regents exam. In this question, we're given two functions, one visually, that's h of x, and then the other function we're just given the equation for, that's g of x equals 2 times the absolute value of x plus 4, and then minus 3. And then we need to kind of compare the two of them. So obviously, we need to graph g of x because we can't see it visually. So on the right-hand side here, you can see I've already got a head start. What I'm going to do is going to plug in some values of x and see what our output, our y values become. I'm going to start with an x value of -6, which would be somewhere along here. And then I'll find out -5, -4, -3, and -2. From there, I should be able to kind of gather what the rest would look like. Okay, so we'll use -6 as an x value, -5, -4, -3, and -2. And so you can see what I'm doing here is I'm just replacing x in this function with our various x values. Okay, so let's go ahead and start solving these. First one here, this is going to become 2 times the absolute value of -6 plus 4. -6 plus 4 is -2. Absolute value of that would be +2. And minus 3. So 2 times 2 minus 3 is 1. Next one, 2 times the absolute value of -5 plus 4. That's -1, but the absolute value of it would be +1. Minus 3, and 2 minus 3 is -1. Next one, -4 plus 4 is 0. 2 times 0 minus 3 would get us an answer of -3. Next, 2 times -3 plus 4, that's 2 times 1, minus 3, gets us -1. And finally, 2 times the absolute value of -2 plus 4, that's 2, minus 3, would get us an answer of +1. So let's go ahead and sketch where these points would be. So when x is -6, y is 1. When x is -5, y is -1. When x is -4, we get a y value of -3. Next would be -3, -1, and finally -2 and +1. So we can see that this does form a pattern here. Something like that. Okay, so let's take a look at our possible answers here. We need to find out which one of these statements are true. First one, g of x has a lower minimum value than h of x. We can see that that's clearly true. This minimum here is definitely lower than that minimum, so that is correct. Next one, it says for all values of x, h of x is always less than g of x. Now that's definitely not true. We can see all that it's in fact the opposite. H of x is always greater than g of x, no matter where it is. So that's false. And then it says for any value of x, g of x is never equal to h of x. And we can see from the graph that that is clearly true. So in the end, it looks like the statements 1 and 3 only are true. That's all, and thanks for visiting JD's Regents Preparation.